if a function is invertible, then you're looking at a situation where the cylindrical shell method would apply. All right. Actually, what that means is that, in general, any method will apply. Right? Washer or cylindrical shell. If there's any kind of gap between the function and the axis of revolution, you can't just simply use the disk method. But if a function's invertible, and all that means is that you can find the inverse, switch x with y, solve for y, that kind of thing, then either method will work. All right. Not to say that you're actually going to be finding inverses. It's just you want it to be something that can be done if you needed it to be done. This is weird. So I'll create the graph again, mark it up, but I'm going to do it, using the calculator. E to the 2x so e to the 2x bounded between the curve x equals 1 and the coordinate axis. So that means in terms of x, that's the furthest I'm going out, x equals 1. So I'm going to go window 0 to 1. I'm going to zoom fit the y min, clear zoom 0. It creates a graph that does not show me the x-axis. I'd like it to show me the x-axis. Depending on what axis you're revolving around, you may not even care. But this time I want it. So I pop in a 0 for y min. So I do the zoom fitting process first so that it squares up the window for me. And then I make minor adjustments as I go, and then hit graph. You never want to hit zoom fit again because that's just going to undo the corrections that you just made. All right, so let me snip this. Top it in. All right, we're revolving this around the y-axis. All right, the adjustment that's made for cylindrical shell method is that the arbitrary rectangle that you create has to be perpendicular to the axis of revolution. Oh, sorry. I emphasize that too. Like I really emphasize every syllable in that word. Perpendicular, what I meant to say was parallel. All right, parallel to the axis of revolution. Okay, so that creates a thickness along the x-axis. All right, the skinny part of the rectangle is along the x-axis. The height of the function, that's a distance, the height of the rectangle is a distance from the x-axis up to a point on the curve. The distance from the x-axis to a point in space is known as y, but specifically, we have a coordinate x comma y. In this case, x comma what y is equal to, e to the 2x. All right, so I now know that the height of this rectangle is e to the 2x. All right, so that's a piece of information that we need. Going back to our general model, so we're just marking it up. Very similar in terms of what information you need. Very similar to the disk and washer method. We still need dimensions of the rectangle, but then we need that extra piece of information, the p value. All right, so the general model is 2 pi on the interval of a to b, the p function times the h function times d whatever, in this case dx. Not always x, but in this case it's x because that's how our rectangle is oriented. The p, again, is the distance from the axis of revolution to the center of the arbitrary rectangle. But since that arbitrary rectangle has infinitesimal width, the center is really anywhere you want it to be. And it all depends on where I place it anyhow. So that p is a distance off of the y-axis. Any point in space that is a distance off of the y-axis would be known as x. The height of the rectangle, h, we just discovered is y, and y in turn is e to the 2x. And we know d is with respect to x. We just need the bounds. All right, so in terms of x, this bounded area starts at 0 and ends at 1. So I'm ready to rock and roll with my function. 2 pi on the interval of 0 to 1. The p is the x. h, the height of the rectangle, is e to the 2x dx. All right. This would be a situation where you'd have to use u substitution in order to integrate. When we did it with the washer method, I can't remember what technique. I think it involved a log. I mean, it would almost certainly have to involve a log. So either way, it's not a technique that we've gone over yet. So to the calculator we go. 2 pi math 9 on the interval of 0 to 1 x e to the 2x power dx. See, this is what infuriates me, because this is my work here, which is a holdover from last class. What this means is that somebody intentionally deleted my program at some point. It's like, what kind of moron does that? It's like, oh, I don't want these programs to be in my way, so I'm going to delete them. They're not in your way. Ah, people. Anyway, so that's your decimal answer. If you don't want a decimal answer, leave the pi out of the calculation. I mean, you might still end up with a decimal answer. But if you want an answer in terms of pi, leave the pi out. You can still leave the 2 in there. You get that. Try to math bracket or something. I mean, there's an exponential e in there somewhere, so odds are it's not going to math frac. Unless it's some really kooky type of number that just works out. Yeah, it's got to be the result of log of something or other. So what this tells me is that there's really no benefit to trying to put the answer in terms of pi, right? Because I mean, if I did, I'd be writing 4.194528049 pi. That just seems stupid, right? So this is good enough. And besides, we know this by now. Oftentimes the question is simply write the integral that could be used to find the volume of the bounded area. Volume of the bounded area as it's revolved around whatever axis.
Like on the exams, you want like a definite answer. Okay, we round.
I'll tell you that the answer needs to be in terms of pi or in simplest radical form or something like that. Every other time you can round it any way you want, as long as the way you choose you can do it correctly. I've had that before. Student comes up to me at the end of class, they get their test back. They're like, they put down the answer 13.1. So you took off credit. You said we could round it any way we want. I said, yeah, you have to do it correctly. You know, so rounding to the nearest tenth, that's wonderful, but that would be 13.2, not 13.1. So don't be that person. There's always somebody. Some of us are worried right now. I know when it's a me kind of mistake. When I was a student, I was like, yep, he's talking about me. Yeah. You know me so well. All right, so function out to x equals 7. So let me make the adjustment there. Zoom fit the y max. There's a zoom 0. Sorry, y min or y max again. It doesn't matter which one you use. I did a y max this time. But again, I want, maybe you don't want, it doesn't matter. We're revolving around the y-axis, so we don't actually technically need to see the x-axis. You still get a sense of it. I think you get a better sense of it if you actually see both axes. So that's what I'm going to do. I just remember when I was a student in Calc 2, all the people who wanted to cheat off of me on like assignments, it was almost always related to something like this, volumes. And the reason why they wanted to is because they couldn't figure out where the integral came from. Because what they were doing was they were just taking the function, slapping an integral symbol on it, and then maybe throwing a 2 pi in front of it and calling it a day. All right? So the rationale behind all of these integrals comes from the appropriate placement of an arbitrary rectangle. It seems stupid, and if your thought process is, because I mean, there's enough people in this room that I guarantee somebody's had the thought process. Well, why does he keep drawing that stupid rectangle? Do we need it? Well, I need it. It helps me come up with the integral. Maybe it doesn't help you come up with the integral. Maybe you get it without any effort whatsoever. But all the people who are cheating off of me, they like, I say rectangle, and they'd be like, what rectangle are you talking about? I'm like, the one he drew on every problem that we've gone over in class. Wait, he went over this in class? I'm like, oh boy. So draw the rectangle. Again, I know it's going to be this kind of rectangle because we're rotating it or revolving it, whatever word you like, doesn't matter, it means the same thing, around the y-axis. And if we're using the cylindrical shell method, the rectangle that you're rotating has to be parallel to the axis that you're revolving around. The other methods, you want it to be perpendicular. This time we want it to be parallel. I'm going to mark it up a little bit less than I did the previous one, just the bare bones, just so you can see. But the thickness is dx. I need the distance separating that rectangle from the axis of revolution, and I need the height of the rectangle. Those are the pieces of information that I need. Okay, whether you call it P and H is your business, it doesn't matter. That's the stuff that we need. The distance from the y-axis to any point in space is x. The distance from the x-axis to any point in space is y. So 2 pi over the interval of 0 to 7. The dx, that defines your interval. That tells you that you're living in the world of x. If I were working with a dy, I'd be living in the world of y. So this is telling me that whatever my bounded area is, it has to be the bounded area with respect to x values. The p, all right, so that's the distance from the axis of revolution. So that's x. The height, h for height, that should be a little easier, is y, and then dx. All right, because it's dx, I want to replace the y. At least until you get to Calc 3 and you learn about how you integrate things that have x's and y's in it, which is way easier than it might seem like it would be. So x, replacing the y with what it really is, x plus 1 to the 1/3 dx. We pop it in. And you know what? If you want, this, you could just leave it in terms of y. If you know that y1 in your calculator is the function you're looking for, and that almost always is the case, then you could write it like this: math 9. I'll put the 2 pi in first. I was going to do it without the pi's to see if I could get an exact answer, but I'll do it with the pi first. So math 9 / I forgot to put the 2 pi. And just try to make up an excuse on the fly, see if anybody would notice. I tend to out myself on stuff like that. So anyway, this blue expression is really what I have in y1, so alpha trace y1, instead of retyping it. I can do this. Or I can actually type it in x plus 1 raised to the 1 fed. Same result. Right? Because odds are you wanted to have a look at the picture of the graph at some point, So you probably type this into your calculator, so it's stored in as y1. If you want to use this notation, don't just write x, y, dx, write x, y sub 1, and then just make a note that you stored this in as y1 in your calculator. You know, for something like this, it's not a big deal to actually write out the function, but if you have some monstrously large function and you don't want to write it out, there's nothing wrong with that. It's not unreasonable to use a shorthand approach. Just for giggles here, let's see if there's a clean answer. Let me just divide out the pi. Constant multiple. Nah, it's not clean. All right, but I didn't expect it to be because this is a cube root. If I'm anti-differentiating a cube root, odds are it's going to be pretty root-ish. Was that? Is it clean?
Yeah.
Math, enter. Oh, it sure is. It was so ugly that I gave up on it. I was like, no way is that going to be fine. But it was. Cool.